Okay, looks like YouTube is on, LinkedIn and Facebook. All right, 10 minutes. Uh, let's talk about three topics. We're going to talk about Wall Street, what's happening in SaaS apocalypse as of last 3 weeks. We've talked about Claudebot already, and we want to tie in the Claudebot into that SaaS apocalypse a little bit because Claudebot came about a few weeks before the SaaS apocalypse. So the SaaS apocalypse that we're seeing today, it's going to continue, and that's why I want to talk about human intelligence before we talk about the Wall Street's SaaS apocalypse. So what's happening in the Wall Street right now, you can peel that onion in many different ways, and I'm sure you can go to YouTube and find many explanations, but I want to use human intelligence as a way to understand that. The risk is not that they don't have any revenue, is the risk is that they don't have a future outlook. So the SaaS company, the software company, software as a service, that's what SaaS stands for. Software as a service company has been around for a very long time, and they have done tremendous amount of hiring and tremendous amount of service providing, and that's what we are accustomed to. So what happens in human intelligence? And let's talk about that before we talk about the SaaS apocalypse, the software 3.0, and Claudebot. So human intelligence works off of human neurons, of course, right? So there's 86 billion neurons and trillions of synapses. So if it's binary, if you want to think about it from a binary perspective, the zero does not have any action potential, but one does. So every time there's a one in human neurons, it either moves up or down or go left and right. So based on that, the firing of the neurons is how we actually maneuver, not just our decision making, but just the simple hand gestures that I'm making right now. This means that if you can get down to a large language model, right? Say, for example, large language model that writes the software these days because of software 3.0, your coding is becoming so much more simpler, so much more efficient, and so much more less power consuming is because of the zeros and ones. Right now, if it requires 64 bits, now you're looking at a 1-bit system that can create a large language model that does not require a $40,000 GPU. It can run off a computer CPU, or it can run on your IoT device that came from China and doesn't require you to do anything other than just install that large language model into it. So you're developing your own software. You're pushing the software in your hardware that you own, hardware that you bought. This creates a headache for future revenue possibility, future outlook for lots of the SaaS companies. And these SaaS companies charges per seat. These SaaS companies charges per customization. These customization can be done today using Claude because you can type in an English language. You can say, this is the functional logics that I need. Go ahead and write code for it and tell me exactly how to deploy that code. Step by step, it all can be done. And instead of 6 months and 500 man hours, labor hours, or human capital, you can do these in 5 minutes, if not 5 hours, right? But the struggle becomes after that, which we're not going to discuss right now. And that's kind of goes into that Claudebot discussion about how the Claudebot will maintain those operations for you and maintain and operate. And instead of having human capitals, it will have agent capitals tied into it. So as we're moving really fast into the human intelligence conversation, last bit of it to tie it all in, the human mind that works in the zeros and ones, yes or no, right? Many decisions, but it doesn't have a deterministic system. It's a deterministic system that has been around for 70 years in the software space. Now we have software 3.0. Now we're going from -1, 0, and 1. So that means you have a little bit of more flexibility in your questions and answers that you have and the decisions you want to make, and yes or no, but also give me a third option. So if you're thinking about it from that perspective, you can see where the software will get into trouble. But here's where you come short. You come short because your data is not speaking to you. Your data is not available to you. Your data is not structured. Your data is not clean. So this is a very good opportunity for anybody who's listening right now to say, how do I use Claude? How do I use these coding programming languages that otherwise was very expensive, wasn't written for my Excel sheet? Because as you can imagine, all the Excel sheet that you have on your desktop right now, what if you could organize it in a way that your data is just right there in front of your fingertip, and you don't have to do all these hard work to sift through those data and use your hours and hours of work that you probably say after 10 years of collecting those Excel sheets, they're just not necessary. But guess what? They're your archive data. Those data are valuable. Those data is what's going to make all the difference moving forward. Because if you can look back further into the past, which say 10 years of Excel sheets, now you can start predicting next 10 years, right? But don't take it as a personal thing. It's more like an enterprise level engagement. Historical data is very, very important in enterprise level decision making. So how does that CloudBot agent come into play? Well, right now you can say CloudBot or the OpenCloud, excuse me, that's the terminology that I should be using. OpenCloud is the new name for CloudBot, and OpenCloud does all these amazing things that, you can take example after example, but you can go look it up on the Google and see the best use cases for OpenClaw. But you can create those agents in CloudBot. Excuse me, you can use those agents in your Codex. You can use those agents in many other places. You don't necessarily have to do OpenClaw because there are secure ways of doing OpenClaw. And that's one of the things that I want to have you take away at the end of this discussion is that OpenClaw is not safe. OpenClaw is not secured. It is a high cybersecurity vulnerability. It will expose your data. And not only that, it will leave you thinking that you're safe, but you're not. There's lots of cybersecurity mindset that you have to build before you start using OpenClaw. But you can start using agents, and agents are becoming dramatically valuable in many of the industries. So if you're thinking about AI and you're not thinking about agents, you will miss out on a lot of the news events that are happening around the AI space. So I'll give you some. Prior to 2025, say back in 2000, a lot of the internet activity was about peer-to-peer payment methods, right? So you can think about PayPal, that came around a long time back, and all of a sudden there's this other equation that came in like Stripe, Square, and so many other payment methods. So one of the ways to measure how serious something is by understanding how does somebody outsource that payment method to that system, right? So used to be PayPal, used to be eBay. Now you're looking at so many other payment systems. It's because the trust is there. And this trust is signifying that it's something that is very well structured and is going to be built on for the future. So recently, Google has put together this agent-to-agent transaction. So that means a thief is no longer consuming or paying for a product. It's a thief's agent that will pay for the product, and maybe a thief will consume it, right? So these protocols are heavily, heavily secured. That means Coinbase, the crypto guys, right? They are going to do transactions between agents, and each agent will represent a specific organization, individual, whatever is behind that agent is not going to be something that everybody will have their visibility to, right? Privacy is what we're talking about here. So these sort of agent-to-agent protocols, agent-to-agent transactions will become the norm in the future, just like it is right now that between PayPal and me and you, we make transactions, right? Now it's going to be agent-to-agent and whatever's in the middle making that transaction. So these agents protocols that are shifting the way we do payments is an early on sign on what's happening in the agent space and how much of an agent we're going to use. This is not something new, and that's okay because further we can look back in the past, further we can look into the future. One of the things that we call agents today is the smart agents, right? But previously they used to be called bots. And these bots have been around for a very long time. So if you're understanding your business process and you want to understand how long you've been using agents, you've been using agents for a while. It's just that you didn't call them agents. You didn't call them artificial intelligence. You didn't call them machine learning. You just call them bots because these bots ran on logics. So one of the things that you really have to add on top of the bots to make it an agent is a large language model. It's a logic that has a large language model as a tool to use that communication even further beyond just the business logic that was, let's say, financially viable at that point. Right now, what's financially viable is that you have an agent, you have a bot, you have logics, you have your business process, and it can go in all corners of the world because of this agent-to-agent protocols. So 8 seconds left. Thank you for listening. I hope you learned something new today. Looking forward to the next Friday's conversation, and be on the lookout for our podcast where we will discuss our mastermind and how, when people, process, and technology is adopting artificial intelligence, what happens during the initial ideation and exploration. We'll talk then. 10 minutes out. Ciao.